Right now, at this exact moment, there are 20 quadrillion ants alive on this planet. If you gathered every human on Earth, we wouldn't even come close to matching the sheer mass of the 20 quadrillion ants currently alive right now. That is 2.5 million ants for every single human breathing. That is a 2 followed by 16 zeros. But how does an animal with a brain the size of a grain of sand build a civilization? That is 2.5 million ants for every single human being currently breathing. For you, specifically, 2.5 million. They were here before you woke up this morning. They will be here after everyone you know is dead. Without a single leader, they engineer climate-controlled cities, execute military raids, farm livestock, and build living bridges out of their own bodies. They have been doing it for 140 million years, and it all runs on a terrifying chemical algorithm that can glitch and cause millions of them to march in a circle until they die. If you gathered every wild bird on Earth, every eagle, every sparrow, every penguin, and then gathered every wild mammal, every wolf, every whale, every elephant, and placed them all on one side of a scale, the ants would outweigh them, combined, by a massive margin. This is not a guess. In 2022, a team of researchers compiled 489 studies from every continent on Earth and calculated the total: 12 megatons of dry carbon, the combined weight of 1.6 billion adult humans, roughly the entire population of North America, South America, and Europe, standing on a scale, matched pound for pound by insects most people step on without thinking. And that number, 20 quadrillion, is a conservative estimate. So the question is not whether ants rule this planet. They do. The question is, how? How does an animal with a brain smaller than a grain of sand build a civilization that outweighs every wild mammal on Earth? Start with what you think you know. There is a queen. She runs the colony. She issues orders. The workers obey. None of that is true. The queen does not command a single ant. She does not direct traffic. She does not make decisions. She is not a monarch. She is a prisoner. A bloated, immobile egg-laying machine sealed in the deepest chamber of the nest, fed and groomed by workers who will kill her the moment she stops producing. No ant controls the colony. The colony controls itself. 8 million individuals. No leader, no central plan, no single communication that any one ant comprehends in full. The entire system runs on chemistry, pheromones laid in trails, detected by antennae, interpreted through 400 distinct olfactory receptors packed into a head the width of a pencil tip. One ant touches another's antenna. A molecule transfers. A behavior fires. Multiply that interaction by 8 million, 60 times a second, and what emerges is something no individual ant designed or understands. A superorganism. A collective that farms, that wages war, that builds climate-controlled cities 3 stories underground. Here is something almost no one knows about ants. Adult ants cannot eat solid food. Prefer not to. Cannot. Inside the mouth of every adult ant is a structure called the infrabuccal pocket, a microscopic filter made of chitin that physically blocks any solid particle from entering the digestive tract. When a forager picks up a crumb and brings it to her mouth, the filter catches it. She compresses the trapped solids into a dense pellet, and then she spits it out. So when you see an ant carrying a piece of food across your kitchen counter, she is not bringing it home to eat. She is bringing it home to feed to the babies. The larvae, blind, legless grubs piled in the brood chamber, are the only members of the colony that can digest solid protein. The adults feed them chunks of insect prey. The larvae break it down with enzymes the adults do not possess, and then the larvae vomit the liquefied nutrients back into the adults' mouths. The babies are the stomach of the colony. Every adult ant on Earth is being fed mouth to mouth by an infant. You know the fable, the ant and the grasshopper. The ant works tirelessly while the grasshopper plays. The moral: ants never rest. In laboratory studies of Temnothorax rugatulus, researchers tracked every individual ant in the colony for weeks. They expected to confirm the fable. 50% of the workers did nothing, not rested between tasks, not worked at a slower pace. They sat motionless in the dark corridors of the nest, their abdomens swollen with stored liquid food, doing absolutely nothing while their sisters worked themselves toward death. Day after day, week after week. They are not lazy. They are not broken. They are a strategic reserve, living refrigerators and replacement soldiers, sitting in the dark, waiting to be activated the moment a foraging party is destroyed. The colony does not trust that tomorrow will be safe, so it keeps half its workforce on ice, hidden underground, doing nothing, just in case everything goes wrong. The most famous symbol of hard work in all of human culture runs on 50% unemployment. In the Mediterranean, along the coasts of Spain, France, and Italy, there is a single ant colony that stretches 6,000 kilometers. 6,000 kilometers. That is the distance from New York City to the western coast of Ireland. A single colony. Billions of workers spread across millions of nests, and every one of them, when they meet, recognizes the other as family. The Argentine ant, Linepithema humil, did not evolve on these coastlines. It arrived on trade ships from South America in the early 20th century, and when it arrived, something unprecedented happened. The individual colonies stopped fighting each other, their chemical signatures merged, their borders dissolved, and they formed the largest cooperative animal society on Earth outside of humanity. Pick up an Argentine ant in Barcelona, fly it to a nest in Genoa, 800 kilometers away, place it among strangers. The strangers will groom it, feed it, accept it as one of their own. That is like a single, unified human city stretching uninterrupted from New York to Paris, where every citizen cooperates in perfect harmony without a single act of violence. Christmas Island sits in the Indian Ocean, 350 kilometers south of Indonesia. For 110 million years, its ecosystem was stable. 40 million redland crabs, each the size of a dinner plate, migrated annually from the forest to the coast, eating dead leaves, turning soil, engineering the entire forest floor. Then the yellow crazy ant arrived, Anopolepis gracilis, small, erratic, nearly impossible to control. They formed super-colonies across the island. They farmed scale insects on the forest canopy, harvesting the sugary honeydew the scale insects produced. And to protect their livestock, the crazy ants turned on the crabs. Millions of ants swarmed individual crabs. They reared up on their hind legs and sprayed concentrated formic acid directly into the crabs' eyes, into their joints, into their mouths. The crabs, armored animals 1,000 times the ant's size, went blind, collapsed, died by the millions. 40 million red crabs, gone. And because those crabs were the only animals eating the dead leaves on the forest floor, the leaves piled up. The soil chemistry shifted. Tree seedlings stopped growing. The rainforest that had stood for 110 million years began to collapse. Not from a hurricane, not from a drought, but from an ant the length of a grain of rice. Ecologists call this an invasional meltdown. The red imported fire ant, Solenopsis invicta, costs the global economy $17 billion per year. 6 billion of that falls on the United States alone. Fire ants destroy crops. They sting livestock. They swarm into electrical junction boxes and chew through insulation, short-circuiting traffic lights, airport runway systems, and air conditioning units. They have caused house fires. They have shut down highway interchanges. In Texas, they cost the cattle industry more than any single predator, including coyotes. Why electrical wiring? The leading theory, when a fire ant is electrocuted by a live wire, its dying body releases an alarm pheromone. That pheromone summons more ants. Those ants contact more wires. More ants die. More pheromone releases. More ants arrive. The colony feeds itself into the circuit until the entire junction box is packed with dead ants, and the system fails. They do not understand electricity. They do not need to. Their chemical programming converts an annoyance into a catastrophe, one dead ant at a time. The trapjaw ant, Odontomachus boweri, holds its mandibles open at 180 degrees, locked by an internal latch made of hardened chitin. On the inner surface of each mandible sit microscopic trigger hairs. When those hairs contact prey, a pair of giant sensory neurons fire. The latch releases. The mandibles close at 145 miles per hour. The entire strike takes 130 microseconds, roughly 2,300 times faster than the blink of a human eye. The acceleration reaches 100,000 g, 300 times the ant's own body weight, delivered in a space smaller than a pinhead. Scaled to a human, that is equivalent to swinging a baseball bat from a dead stop to the speed of a bullet in a fraction of a millisecond. At that acceleration, human bone would not fracture. It would vaporize. But here's the part no one expects. The trapjaw ant does not always use this weapon on prey. When cornered by a predator too large to kill, the ant points its mandibles straight down at the ground and fires. The force of the strike against the dirt launches the ant backward through the air in a perfect ballistic arc. It rockets away from the predator like a biological ejector seat, propelled by the impact of its own face hitting the ground at 145 miles per hour. An ant's neck is a problem. The head and the thorax connect through a joint narrower than a human hair. That joint bears the entire load of anything the ant carries in its mandibles: food, soil, larvae, enemy corpses. In 2014, engineers at Ohio State University placed individual Allegheny mound ants in a centrifuge and spun them at increasing speeds to determine the exact force at which the head separates from the body. The neck held at 3,400 times the ant's body weight. Some specimens endured 5,000 times before failure. That is a 200-pound human hanging by their teeth while supporting the combined weight of two fully loaded Boeing 747s. Without their neck snapping, the secret is not muscle. Ant necks have very little muscle tissue. The joint is held together by a collar of soft tissue that interlocks with textured surfaces on both the head and thorax, creating a mechanical bond that distributes force across a microscopic area with engineering precision that aerospace researchers are now actively studying for robotic joint design. Army ants, Eceton burchellii, are completely blind. They navigate the rainforest floor by following the pheromone trail of the ant directly in front of them. Nothing else. No landmarks, no memory, just the chemical scent of the sister ahead. If a foraging column is disrupted by heavy rain, a fallen branch, a gust of wind, and the lead ants accidentally curve back and cross their own trail, the system breaks. The ants begin marching in a circle. Each ant follows the one ahead. Each ant lays more pheromone as it walks. The trail grows stronger with every revolution. More ants are pulled in from the surrounding area, drawn to the intensifying signal. The circle tightens, accelerates, grows. In 1921, the naturalist William Beebe documented an army ant death spiral in Guyana that measured 1,200 feet in circumference. A single ant took 2.5 hours to complete one lap. The ants marched for 2 full days. They did not stop, they did not eat, they did not break formation. They marched until they died. Every single one. The same algorithm that coordinates millions of ants across miles of jungle, that builds living bridges and executes military raids with perfect precision, that algorithm contains no error correction, no override, no off switch, and when it loops, it kills every ant that touches it. But the most horrifying thing in an ant's world is not a glitch in their own programming. It is something that hijacks it from the outside. You have heard of the zombie ant fungus, Ophiocordyceps unilateralis, the fungus that controls ants' minds. Except it does not control their minds. It does something worse. A foraging carpenter ant brushes against a fungal spore on the forest floor. The spore uses enzymes to drill through the ant's exoskeleton, the hard outer shell, and enters the body cavity. For weeks, the fungus grows silently inside the ant, consuming non-vital tissues, spreading through the body. The ant continues foraging, continues feeding the colony, continues behaving normally. It does not know it is already dead. When the fungus matures, it does not infect the brain. Scientists assumed for decades that it must, that mind control requires brain control. In 2017, a team using deep learning 3D electron microscopy mapped every cell inside an infected ant's body. They found something no one predicted. The fungus builds a 3-dimensional network of interconnected tubes that physically wraps around the ant's individual muscle fibers. Not the brain, the muscles. The fungus becomes a second skeleton, a puppeteer that grips every string. It secretes chemicals that force the ant's leg muscles to contract and release. The ant walks, it climbs, it navigates. But the ant is not choosing to do any of this. The fungus is pulling its limbs like a marionette. And the brain, the ant's actual brain, sits untouched, perfectly intact, fully functional. The ant is conscious. It can perceive everything happening to it. It feels its body moving. It feels itself climbing a plant stem, exactly 25 centimeters above the forest floor, the precise height where temperature and humidity are optimal for the fungus to reproduce. It feels its jaws clamp down on a leaf vein with a force it cannot resist, as the fungus drains the calcium from its mandible muscles and locks them in permanent rigor mortis. And then the ant dies, and a fungal stalk erupts from the back of its head, and spores rain down onto the foraging trail below, where its sisters are walking. The ant was not a zombie. A zombie's brain is gone. This ant's brain was kept alive on purpose, so the body would keep regulating its own temperature, its own breathing, its own balance, while something else drove it to its death. The fungus enslaves the body, but there are ants that enslave each other. Polyergus ants, the Amazon ants, cannot feed themselves. They cannot care for their young. They cannot clean their own bodies. Their mandibles have evolved into smooth, sickle-shaped blades with no teeth, optimized exclusively for killing. If you place a Polyergus colony in a container with food piled around them, they will starve to death, unless a slave ant picks up the food and places it into their mouths. They survive entirely by enslaving other species. A newly mated Polyergus queen locates a nest of Formica ants. She charges in alone. From a gland in her abdomen, she releases a compound called a propaganda pheromone, a chemical that does not mimic the host colony's scent, but instead triggers raw, uncontrollable panic in the defenders. The Formica workers scatter. The nest falls into chaos. The queen walks through the confusion, directly to the royal chamber. She finds the Formica queen. She leaps onto her back, and she drives her sickle mandibles through the host queen's skull. Then she bathes in the dead queen's blood. She absorbs the chemical signature, and when the Formica workers return, they detect their queen's scent on this stranger, and they submit. They groom her, they feed her, they raise her offspring as their own. When those offspring mature into adult Polyergus workers, they launch organized raids on neighboring Formica colonies. They deploy the same propaganda pheromone their mother used. They kill the defenders, and they steal the pupae, the developing babies, and carry them home. The stolen Formica babies hatch inside the Polyergus nest. They chemically imprint on their captors, and they spend their entire lives as slaves, foraging, cleaning, feeding, and raising more Polyergus raiders who will go out and steal more babies. The cycle never stops. In the tropical forests of Central America, acacia trees provide everything an ant colony could need: hollow thorns for shelter, protein-rich nodules for food, and a constant flow of sweet, golden extrafloral nectar. Pseudomyrmex ants move in. They patrol the tree's branches. They attack any herbivore that lands on a leaf. They prune competing vegetation that grows too close to the canopy. The tree thrives. The ants thrive. Textbooks call this mutualism, a partnership where both sides benefit. It is not a partnership. It is a hostage situation. The nectar contains an enzyme called chitinase. When a newly hatched Pseudomyrmex ant takes her first sip, the chitinase enters her digestive system and permanently destroys her invertase, the biological tool her body needs to break down standard plant sugar. Sucrose, the sugar found in every other plant in the jungle. One sip, irreversible. From that moment on, the ant cannot digest the nectar of any other tree, any other flower, any other plant on Earth. She can only process the pre-digested sugar the acacia provides. If the colony tries to leave, if the tree is damaged, if a storm knocks down a branch, the ants will starve. Their own biology has been sabotaged. The tree addicted them with the first drink and crippled them so they can never leave. The ants do not defend the tree out of loyalty. They defend it because they will die if they stop. In most ant species, your caste is permanent. You are born a worker. You live as a worker. You die as a worker. Your biology is fixed from the moment you emerge from the cocoon. The Indian jumping ant, Harpygnathos saltator, breaks this rule in a way that should not be biologically possible. When the queen of a Harpygnathos colony dies, the workers do not spiral into collapse. They fight. Females strike each other with their antennae in ritualized dueling tournaments that last for weeks. The winners are not simply promoted, they are remade. The victorious ant's brain physically shrinks. 20 to 25% of her neural tissue dissolves. The regions responsible for complex foraging, spatial memory, and visual processing. Simultaneously, her ovaries expand to fill her abdominal cavity. Her body chemistry shifts. Her life expectancy surges from 6 months to more than 3 years. She becomes a gamergate, a worker who has transformed herself into a reproductive queen. That alone would be extraordinary. But the Indian jumping ant goes further. If a Gamergate is overthrown by a rival, challenged, defeated, demoted, the process reverses. Her ovaries shrink. Her brain regrows the lost neural tissue. 25% of her brain mass regenerates, and she returns to her original state, a worker with a normal lifespan, a full-sized brain, and no reproductive function. Scaled to a human, that is a CEO dissolving a quarter of their cerebral cortex to live to 800 years old, and then regrowing the missing brain tissue the day they lose the job, returning to a normal 80-year lifespan. No other animal on Earth can do this. Ants emerged over 140 million years ago, during the mid-Cretaceous, evolving from solitary wasp-like ancestors. For most of their history, they were small, unremarkable, background players in ecosystems dominated by reptiles. Then came the Eocene. 49 million years ago, during a period of extreme global warming, the genus Titanomyrma walked the forests of what is now Germany. Queens of Titanomyrma gigantea measured 7 centimeters long, nearly 3 inches, with a wingspan of 16 centimeters. The size of a hummingbird. A flying ant the size of a hummingbird. Fossils of Titanomyrma have been found on both sides of the Atlantic, in Germany and in Wyoming. The leading hypothesis, during the Eocene thermal maximum, when Arctic temperatures were warm enough to support forests, these giant ants crossed intercontinental land bridges through the Arctic to colonize North America. Today, the smallest ant on Earth, Carabara atoma, is less than 1 millimeter long. You could fit 70 of them, end to end, across a single Titanomyrma queen. The family spans 4 orders of magnitude, from a flying insect the size of a bird to a creature smaller than a grain of sand. 15,700 described species, thousands more unnamed. On every continent except Antarctica, every super-colony, every empire, every death spiral and slave raid and living bridge. All of it begins with a single flight. After a heavy rain, mature colonies across an entire region synchronize. Millions of winged ants, virgin queens and males, pour from their nests into the open air at the same moment. The male ant exists for this and nothing else. His brain is reduced. His body is fragile. His eyes are enormous. He flies. He finds a queen. He mates with her in midair. His reproductive organs avert into her body, and the force of it leave-in action senilely him, kills him. He falls from the sky. His life lasted minutes. The queen lands. She reaches behind her back and tears her own wings off. She digs into the soil. She seals herself in darkness. She will never see the sun again. In that underground chamber, she begins to lay eggs. She fertilizes them using sperm stored in a small internal organ, a supply she will keep alive and use for up to 30 years. She feeds her first larvae by metabolizing her own wing muscles, the muscles she will never need again, and by producing unfertilized eggs whose sole purpose is to be eaten by her young. She starves herself to build the first generation, and from that generation, everything follows. Army ants, the same species that dies in death spirals, also build structures out of their own bodies. When Eceton burchellii encounters a gap between 2 branches, the lead ants do not stop. They step into the void. They grip the edge with their tarsal claws, the hooks on their feet, and extend their bodies into open air. The ant behind grips the first ant's legs. A third grips the second. A chain forms, then a lattice, then a bridge. The living bridge shifts its position in real time. As traffic increases on one side, the ants on the other side release their grip and reattach at a new angle, widening the path. They are computing the optimal geometry for traffic flow using nothing but the physical pressure of footsteps on their backs. No ant designed this. No ant understands the shape. The bridge is an emergent solution, arising from millions of local interactions, each ant responding only to the ant touching it, and the collective producing something no individual could conceive. That is like 50,000 human commuters locking their arms and legs over a canyon to form a suspension bridge, and then dynamically reshaping it every 30 seconds so their coworkers can walk to the office 10% faster. Computer scientists at MIT and Stanford did not miss this. Neither did robotics engineers at Harvard. Neither did network architects designing the routing protocols that govern the internet. The algorithm an ant uses to choose a foraging path, reinforce what works, abandon what doesn't, never rely on a central controller, is the same algorithm that routes your data packets across the internet right now. It is called ant colony optimization. It solves problems in logistics, telecommunications, and protein folding that stagger traditional computation. 20 quadrillion ants, no leaders, no blueprints, no understanding of what they are building, and yet they have been solving problems for 140 million years that human engineers only discovered in the last 30. The next time you see an ant on your kitchen counter, carrying a crumb it cannot eat, walking a trail it did not plan, serving a colony that will replace it without hesitation, understand what you are looking at. You are not looking at an insect. You are looking at a single cell of the most successful organism in the history of this planet. An organism that outweighs every wild mammal and bird on Earth. An organism that farms, wages war, takes slaves, builds cities, and processes more soil than earthworms. An organism that was here 100 million years before the first humans stood upright. It does not know you exist. It does not need to.